How are you and feel welcome. Today, just want to take you through a question on the use of trapezium and also the mid-ordinate rule to estimate the area of some regular or irregular figures. Now the question goes that the diagram below is a sketch of a curve y equals to 2x squared plus 1 and y equals to x squared plus 1 drawn on the same grid. So the graph of those two function is provided here, where this line is for y equals to 2x squared plus 1, and this one is y equals to x squared plus 1. So the question goes that using the trapezium rule with 5 strips, estimate the area bounded by the curve y equals to 2x squared plus 1 and y equals to x squared plus 1 and the line x equals to 0 and x equals to 5. Question 2 also goes that using mid-ordinate rule with 5 strips, estimate the area bounded by the curves y equals to 2x squared plus 1 and y equals to x squared plus 1 and the line x equals to 0 and x equals to 5. Now I'll start with the first one, that of use of the trapezium rule. And using the trapezium rule, we'll first of all tabulate a table and get some figure related to this trapezium or the figure given. And I want you to consider this table that I've provided. Now the values of x ranges from 0, 1, 2, 3, 4, and 5. That means I've gotten the height to be 5 minus 0. That is 5 minus 0 divided by the number of strips. And therefore, we are getting the height of each strips to be 1. So I'll start with the first one being 0, then 1, then 2, then 3, then 4, then 5. Then I'll substitute these heights in the respective functions to get the value of y. I'll call this one y1 and this one y2. Now substituting 0 here, I'll end up with 1. Substituting 3, I'll get 3. If I substitute 1 here, I'll get 3. Then 9, 19, 33, and 51. Similarly, I'll substitute the values of x in this particular function, like 0 into x will be 0 plus 1, which is 1. Then I'll put 1 here, which will be 2. Then I'll put 2 squared to be 4 plus 1, which is 5. I'll put 3 squared, 9 plus 1, 10. I'll put 4 squared plus 1, 17. And lastly, 5 squared plus 1, 26. Now, because we're interested with this area that is in between the two curves, then to get the heights of each height, we are going to separate the two. We are going to subtract y1 minus y2 to get the difference. And that difference is going to be the heights that we require. For this case, y minus 1 will be 0, 3 minus 2 will be 1, then 9 minus 5 is 4, 19 minus 10 is 9, 33 minus 17 is 16, and lastly 51 minus 26 is 25. Once I have this table, then I'll proceed straight to the formula. And the formula for the mid-ordinate rule, as we know, is a half the height, first height plus the last height, then twice the mid-ordinate or the mid-heights. Now, by recalling this formula, we will then substitute these heights into this formula, and by so doing, we have area equals to the first height is 0 and the last one is 25, twice the mid-heights, which is 1 plus 4 plus 9 plus 16. Summing up this and multiplying by half, we end up with our area being 42.5 square units. So using the trapezium rule for this particular figure, then the area in this center part here is going to be 42.5. The question B was going that using mid-ordinate rule with 5 strips, estimate the area bounded by the curve y equals to 2x squared plus 1 and y equals to x squared plus 1 and the line x equals to 0 and x equals to 5. We've already used the trapezium rule and we've gotten the correct answer as earlier provided. Now again, we are going to tabulate the table as we did for the trapezium rule, and by so doing, remember we need first of all to get the height, and we know that the height is gotten by 5 minus 0 divided by the number of strips, so it will be 5 minus 0 divided by 5. So it tells you that the height of this mid-ordinates rule will be 1. Now I'll first of all tabulate those values of x and then come to the second one to get the mid-ordinates, the mid-heights or the mid-ordinates. Now for this one, between 0 and 1, it's 0.5, that is the mid. Between 1 and 2, the mid is 1.5. Between 1 and 2, we've said it's 1.5. Between 2 and 3 is 2.5. And between 3 and 4 is 3.5. And between 4 and 5 is 4.5. So this height, that is 0.5, 1.5, and 2.5, 3.5, and 4.5 are therefore referred to as the mid heights. Once I've gotten these mid heights, I proceed to substitute these mid heights to the respective function to get the values of y's. And if I substitute this one, I'll get 1.5 for the first function, 5.5, 13.5, 25.5, and 41.5. I'll do the same. I'll substitute these mid heights to the second function, and by so doing, I'll get 1.25, 3.25, 7.25, 13.25, and 21.25. Again, because we're interested with the area that is enclosed by two curves, I'll get the difference of the heights, which will be equivalent to the heights that we require to calculate that particular heights or area. And therefore, what I'm going to do, I'll subtract y1 from, that is, I'll subtract y2 from y1, and by so doing that one, I'll get 1.5 minus 1.25 to have 0.25, 5.5 minus 3.25 to have 2.25, 13.5 minus 7.25 to have 6.25, 25.5 minus 13.25 to have 12.25, and 41.5 minus 21.25 to have 20.25. Once I have these mid heights, then I'll proceed on to the formula, and we know that for the formula of the mid heights is actually the formula for the median is actually the height and then multiplied by the summation of the mid heights. And therefore, we will substitute the mid ordinates into that formula, and by so doing, we will have that A equals to 1, that is the height, 0.25 plus 2.25 plus 6.25 plus 12.25 and plus 20.25. By summing up that, then you end up with your correct answer being 41.5 square units. Now, I believe that provision of the example has actually reminded you on how to solve these particular questions, especially when you are using mid-ordinate rule and trapezium rule. Please, you can subscribe for more interesting lessons to follow. Thank you and be blessed.